Hey, welcome everybody back to our robotics series. This is a series of presentations that we have built around the Intelitek ER4U robot. We are developing a series that will help you understand how to program and work with the Intelitek robot. I guess they used the word ScorBOT. I just reached around and looked at the machine. So this is robot number 8. We finished off robot number 7 with talking about loops and remarks, and we're going to use the same strategy here. A loop is a mathematical calculation so that the robot then can use limited number of moves, but could move thousands of parts given let's say a flywheel from an engine, and it has to go through a number of machining processes. Rather than writing a specific code for each one of the parts, we can write a loop that will do thousands of parts with very few programming processes and create a mathematical formula that when it reaches a certain limit, then the robot then would stop and then put itself away. So let's go ahead and get started. We start with our cell setup, and today we're going to add a few more pieces, starting with new. Remember then that when we use the roller ball, that we can tilt the manufacturing floor both back and forth like this, and if I push the right mouse button down, I can move it from rotate in, and I can zoom. The new object list always pops up. If you happen to lose it, it can be gotten back from the cell setup toolbar under new objects, and you can repeat that as many times as it's necessary. So let's go get the robot. When you pick OK, you have a choice of no slide base or a slide base, which would be a 1 meter long. These are the ones that we have here in school, are all the 1 meter ones, but we're not in any hurry to we have no slide base for these operations. So the first thing we're going to do then is put the robot out there. Okay, next we want to slide a table underneath that. Under general, you'll find the table. You can change the color of the tabletop. I always suggest, though, that you try to keep it in the lighter color ones, so that if you use a dark color, then sometimes the cubes disappear. Let's kind of use that sky blue. Please leave the tabletop the size that it is. Now put it somewhere on the construction floor, on the factory floor, and then we'll take the hand and then we'll grab it and place it just like this. I always like to keep the robot to the back of the table, so I have all this real estate to be able to put parts out in front. So we're going to use 4 cubes today. We're going to stack them up over on the side, and we're going to give the cubes a position of a 250, negative 260. So that'll put it to the left side of the robot. So again, when we use these cubes, be sure that you use extremely different colors with them. If you try to put all red, when we stack them, they all have a tendency to fall into one another. Doesn't matter what material you use, I just leave it at plastic, and then the 40 millimeter by 40 by 40. Don't change those sizes because our lab exercises are set up for the 40 by, and that's actually the size cubes that we use with the real robot. So we'll want to make sure that you use that, and then we'll place it down on the table. Be sure to set it on the tabletop. If you set it anywhere else, it kind of locks it in at the height, and you're not going to be able to put it back on the table. So the only way you can drag it is from side to side. You can't go up and down. Double snap on that cube. You have 3 things you can do with it. You can rename, rotate, and position it. So we're going to rotate that to be 45 so that we can grab the cube on the side rather than on the corners. And then in the position that we're going to use, the cubes are at 250 for the X and negative 260 for the Y. All right, so we're going to stack 4 top of one another. Again, use extremely different colors. Doesn't matter which colors you use. Rotate to 45. Now we can rotate the cubes, or we could rotate the claw arm if we need be. It's just easiest right now. 250, negative 260. Teach. Let's go ahead and do how about this brown? Put that arrow right on top of the next one. Position 250, negative 260. And then the last one, we could use, let's say, a yellow. Rotate 45. $250, negative 260. Okay, so those are the cubes that we're going to use. Now, we're going to put some storage bins out there. We're going to use 3 storage bins. Storage bins are storage under storage devices. So we're going to have a bin. Now, there's not much choice in a bin. Put 3 of them on the table and then we'll line them up. The bins as well can be positioned as the 3 choices we have. We're going to leave them straight as they are, but we will find a position for them. Bin number 1 is at 250, negative 80. Bin number 2 is at 250, 100. And the last bin number 3 is at 250, and the Y is 280. Okay. So we are going to use 3 of the cubes. We're going to place them in each one of the bin, and as then we fill the bins up, we're going to say then, oops, we're all done with our programming. Our bins are full. The robot then needs to make a decision and then go back to its own position. But we are going to use our loop control then to create as short a possible programming as possible, and we could use a never-ending stack of cubes and bins if we choose to. So, want to save this. So let's go save as. Let's save it to the desktop. Up, desktop. Make sure you double click on that. And then we'll call this robot number 8. Okay. All right, so let's go to our robo cell and let's start a new program. Whenever you start a new program, a couple things you need to do. Number 1 is make sure that you move the L1 to Pro, because we are professionals. That gives us a better list of things that we can work with and more opportunities. And then the other thing is that we immediately want to go ahead and program our home position. Our home position then is 1300330. It's a good idea to memorize these. Negative 90, and the number in itself is 99. Here, you must hit the teach button, in order to record it. So let's go ahead and get the robot. So under File, Import. Now wherever you've saved it, I've been saving it to the desktop so I can easily retrieve it. There's my robot number 8. And then here's what we have that we just did. Now again, I recommend that you not close it out. Make sure that you leave it up on the screen so that if there's a mistake, we can quickly go back to it. We've imported it. Let's just move it around. Some of the same commands that we had before, that the roller ball and right mouse button do the same thing. Let's hit our teach command. Let's put add that 99 to our list. Open the grip. Let's see if it works. Now again, let's just go over how we make the robot move. On the toolbar across the top, we can move it a single line at a time. We have a single cycle, and then we can do continuous. Next, under the Run command, this menu, we have single line, single cycle, continuous, and then we have the word stop. You can also use the F keys, F6, 7, and 8 respectively, and then the stop button would be the F9. We also have this big red stop button which works right here. So those are the pieces that we have. So let's see, let's do a single cycle. Let's put the blue line at the top and then hit the single cycle, and let's see if we can get it to go home. And open the grip. Yeah, baby, that's what we got. So we know the two are connected. Also under the option command, you just want to make sure that the check mark, and I forgot to say this in a couple of the videos, that it's under simulation. If we were to try to click it online, that actually moves the control from the simulator to the real robot, which is hooked up through a USB cable into the back. So we want to make sure that we're always on the simulator. All right, next. So let's go down and add some programming. Our cubes are going to be positions 1, 2, 3, 4, and they're set at a position of 250, negative 260. The only thing that we have to change is the Z command on how high they are. So if we choose to start with our bottom cube, call that position number 1. $250 for X. Y would be negative 260. Our Z would be 17.5. The negative 90 and 0, and make sure you hit teach. Now our second position, number 2, would be our red cube. These X and Y can remain the same, but I have to grab it just a little higher. And since they're 40 millimeters apart, you add 40 to 17.5 and you end up with 57.5. Hit teach. Number 3 is the brown cube. X and Y remain the same. We just have to reach a little higher, and that would be 97.5 and teach. And then position 4 then would be, if you add the 97 plus 40, you end up with 137.5. All right, 1, 2, 3, 4. Red, blue, brown, yellow. And then a position that would be over the top of that, we can add, we can create any number that we would like. So let's just call it position 100 so that it doesn't interfere with any of our mathematical formulas. So we can make that position 100 over the top, and then that would be Let's call it 200. That gives us over the top of this, above that stack, and teach. So we have the 1, 2, 3, 4, and then the number 5th position then would be above that, and that we call that position 100. Now, let's add positions over each of the bins, and I have down those written down as positions 5, 7, and 9. Our Z coordinate will still be all of the 200, so they'll be over the top. So our first position would be number 5. So where did we put the first bin? The first bin is at 250, negative 80. It's at the 200 level, and we'll teach. Bin number, over bin number, the next bin would be number 7. Bin number 2, 250, 100. And then we'll leave it at that. Leave it over above. And our next over above is number 9. And that Y would change to 280. And we'll leave it at the 200. All right. So let's get in the bin below. So number 6 and 5 are related. So the bin number 1, 250, 180. Now we're going to change this a little bit. Now the bottom, the bin itself has a little thickness. So if we leave this at the 17.5, we're going to have impact because the bin has got a bottom to it. So let's just use 23. Now the cube will drop just a little bit, but not bad. And by putting 23, then we make up for the distance that the bin bottom has, and we won't end up with the impact. So, and now 7 and 8 are related. Again with over bin number 2. So the 250, 100. And the 23, and the last one then, even number 10. Change our Y to 280. Everything else remains the same. And then hit teach. So this is then, bin number 1 is associated with position 5 and 6. Bin number 2 is associated with 7 and 8. And bin number 3 is associated to 9 and 10. Well, that really is all the ones that we need. So then we should have, when we look under here, we should have 1 through 10, plus this 100 one, which would be over the stack, and also then 99, which is our home. So we'll need to make 3 changes. You know, when we look at our system, we need to assign names to our first position, our first cube. We'll need to make, with our first drop, and then we need to make a name for our first bin. So let's go ahead and do that. We'll do that right away before we get started. And those then would be all setting variables. SV. Now I move the picture, the import over here on the other side. If I leave it here, it'll disappear. And I'll probably lose it at some point or another. I'll make a mistake. It's just a matter of going and getting the image and put it back on again. So let's do our first one for home, and we're going to call that position 99. We already have that 99 we've already used, but we can either say 99 or we can say home. Our next one then is pick, which relates to the stack of cubes. And the top cube is number 4. Our first drop is associated with bin number 1, and that is number 5. And our first bin is number 6. Well, there you have it. So we've created some words for some of the positions that we wrote. So home is 99, our first pick position, which would be our cube. Now you could use, instead of using the word pick, you could use the word cube. Might be more advantageous. You know, all you have to do is double snap on it, and if you don't like the word pick, you could say, okay, well, that's the cube, the first cube that we got. So cube with position number 4. We could use that, I guess. Cube. Doesn't matter what word you use, as long as you write it correctly. All right, so we're going to go drop over a given bin, and then our first bin is position number 6. The second bin is position number 8, and the third bin is position number 10. But we're really going to be concerned, though, is about our cube. So we'll write the formula based on the word cube. All right, well, let's do some basic programming here then. So the first place that we're going to want to move is to position over 100, because that's where we want the cube to go, or I should say the robot to go, to be able to first pick up the first cube. All right. Now, you better run this from the top, though, because then it will engage all of these words, because we want to start using these words right away. So let me just recycle this. Start from the top, so that all of these words then will be engaged. There we have it. So now we want the robot to grab that first cube. So instead of pulling up position 4, what I can write is the word cube, because we've asked cube now to be number 4. So if I use that and do a single line, notice that it's going to go right to the top and grab the yellow cube. So I want it to close the grip. Yep, that's a good plan. So I'm going to force it to close the grip. So let me do a single. Boom. Now we want to go back to position 100. You always want to be up in and out of the cells safely. Single line. And where do we want it to go first? We want it to go over the first drop. So let's have it move to drop. Now we could call it, we could write number 5, but let's go ahead and use the word drop. And have it go, and I guess, and see, there you go, right over that first bin. And now we want to put it down, so let's put it in the bin. That would be position 6. But since we already have a name for it, let's call it bin. And we'll put it down as a single line. Okay, very good. Oop, and see, now I did have impact. So I need to go back and adjust my position number 6. So I need to get the numbers for position 6. And there they are. So it looks like 23 had some impact. So let's go to 20, I don't know. I know 27 it won't smash into it. Now remember to teach it. And I better change, let's get the numbers for position 8. Change that to 28, 27. Guess what we're using? And let's get the numbers for number 10. I'll get those numbers. Now we can change it then to 27. And then the most important thing then is to teach. So there you go. So that's how you would adapt on the fly. So let's just make sure that that happened. Get those numbers, yup. And yup. And the last one, yup. Okay. So that should work. So let's just try this. Let's go back up. Back down. And you see we don't have impact. Okay. We want to let that thing go. So we want to leave it there. So we want to open the grip. So let's have that happen. Single line. We want to move back now to the drop position, which was number 5. We called it number 5. Let's have it go back up. And then we could have it swing over to position 100 again. Now, before we do that, at this point then, let's start adding our, let's have it run through all of the reposition numbers before we send it over to 100, because it's going to go back to 100, because right now we want it to go back to the top, and to get it to do that, we want to start a loop. And our loop is called a label. So we can put that label up there, and eventually, as soon as I get done with all the calculations, well, I'll tell you what. Let's add those calculations first. Okay, so right here then, let's add this variable. So now to our to our cube one. So we want from 4, we want to go to 3. So we want to go to position 3. So then cube is -1. So that would change it to 3. We want our drop to go to the next bin, which would be a +2 kind of situation. So we want to have drop +2 and 6, 8, 10. So we need then our bin to be bin +2 as well. So after we go through this, cube is no longer position 4. It's 4 minus 1, so it'll be 3. Our bin was 5, so now it'll be 5 plus 2, and now it'll be position 7. And our bin was position 8, so, or I should say it was 6, now 6 plus 2 now will be 8. Next time through it does it again, so -1 it would be 2, +2 would be 10, +2, or I'm sorry, +2 would be 9, +2 would be 10. But now we want it to jump back to the top. So then let's say jump to loop. So let's give it a name. So after it gets all this through, we want it to jump back to the top. So we'll use the word loop. So we need to put it right here and LA is that label, loop. So when you put the blue line here, when you add this, then it just inserts it and pushes everything down. So this is the loop that has occurred that will continue to move to all three of the bins, and we did it only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 commands, and we could move hundreds and hundreds of cubes. The other thing, though, is right here, we need to make it a decision, though, to make sure that there isn't a situation that we've ran out of bins or that we've run out of cubes. So we want to actually put an if jump there. So we need to consider that we don't want that third cube to go there, so we don't ever want it to go and grab position 1. So we want to say then that if cube is ever less than 2, if the calculation comes up that if it's ever less than 2, we want it to jump to the end. So we want to have it stop the program. We want it to go to the end. So if this number, if the cube is ever less than 2, now if it's at 2, 2 is not less than 2. So that makes this false, so it'll continue to jump back to the top. But if it is complete, and we do have now where it's gone through the formula and says now cube is 1, 1 is less than 2, we want it to jump to the end, so let's put that label right there. And what do we want to happen? LA. What do we want to happen at the end of the program? Well, we want it to go home, which we put 99, and we want it to close the grip. I'll tell you what, we put our labeling on steroids. We only did one for position robot number 7. We only did one calculation like this. Now we've added 3 separate calculations with the using the cube, so we've kind of done it up on steroids. But this is the easiest and most efficient way to do it, to be able to come back and to do all 3 cubes, and then once it's done, 3 of the cubes filled up the bins, we want it to return back to the home position. So let's go ahead and restart this. Let's put this up here in the left-hand corner. We can grab the robot and have it start right from the beginning. I'm going to put the blue line at the top, and let's see if we can get this thing run correctly. So what we're hoping to have happen is that cube number 4, we've called it number 4, we'll get into into the first bin, which we called it position 6, and it went over the top at position 5. Now when it gets to the bottom, now we're looking for cube number 3 because we minus 1, and now we're at the second bin, which should be 6 plus 2 would be number 8, and over the top of it, it's 5 plus 2 would be 7, so 7 and 8. But cube 3 this is false. Cube 3 is not less than 2. So if this is false, goes to loop, jumps to the top. So now, looking for our next time through. Next time through then, bin then gets turned into position 10 plus 2. Our drop gets 2, turns into 9. And then it gets back here and turns from cube 3 minus 2, and then it will drop it over here. So at the very last one though, even though it is programmed itself for a 4th bin, it does say though that, 2 minus 1 is 1, so 1 is less than 2, so you're going to jump to the end and then put yourself away. So with any luck, this should work. So we really went from robot number 7 to 8. We've really done our labeling on steroids. So let's see what happens. Take it from the top. All right, let's open the grip. Position 100. Get a cube. That cube was position 4. Drop to 5. Drop to 6. Open grip. Then it comes back out. All right, so everything changed. Cube 3. Now positions 7 and 8. And notice then that we changed our drop a little bit so that we wouldn't have impact. Here we go. So now we're at cube 2. Drop went to 9. Bin went to position 10. Comes back out. Now watch it run through. And now it says, yeah, there it is. So it did figure it out. So cube turned into 1. 1 is less than 2. The robot put itself away. Ladies and gentlemen, we've completed the exercise. Hey, it did it. So, and we've completed those cubes, you know, in less than 25 moves to run the whole process. This could have been, we could have had 4 bins, we could have had 10, 12, 18 bins. We could have stacked these cubes up as high as we wanted. And as long as we had the position set up, this robot would continue to move cubes into the appropriate bins. And then when this last statement, when it got to number 1, number 1 is truly less than 2. So let's jump to the end and put ourselves away. So there you have it, ladies and gentlemen. We went with our remarks. Remember that we're asking at any point we can write something on here, and with that remark, the robot doesn't read that in its programming, but it's nice for the as we look at it as a programmer. And I just like them in all caps. There you have it. At any given time, you could we could put remarks here at the beginning where we could label it. Let's just say, let's call it loops and remarks. Remember that the controller doesn't read these numbers, doesn't read these words when we use it as remarks. So they're oblivious, or the robot is blind to them, and it just helps the reader then to understand what they're seeing. So, hey, thanks for coming. This is our robot number 8 in our series.